In this video today, we want to look at functions from verbal description. So we're coming up with functions. This is similar to our last section where we looked at max and mins. But we want to just write the function. And once we have that, we will continue with looking at some max and mins from those functions. But first, we just kind of want to talk about functions to start off. If I consider these two functions, the first one, y equals 2x plus 3. That we say is y is a function of x. That means we substitute in an x and we find y. If I told you that x equaled 2, you would then say, well, y is 7. If we write the other way, we could write it as x is a function of y. Y equals 7, and then x would be 2. So you can see these are the same formula. They're the same equation, but they're written as either y is a function of x in the first one, or x is a function of y in the second one. And what we're looking at is what variable do you put on the left here by itself. So as we do these problems, and it talks about solve for y as a function of x, you have to think about which way are you going to solve. So for example, a equals pi r squared, area of a circle. We want to write r as a function of a. So what that means is we want to end up with r equals. So I have to try to solve for r. My first step would be to divide by pi. And my second step would be to take the square root of both sides. Now normally we have to worry about square roots of doing plus or minus. Since we're talking about area and radius, I'm not going to worry about that right here because you can't have a negative area or a negative radius. So here is r as a function of a. What about circumference? Write r as a function of c. Well, here I can just divide by 2 pi, and I get r. So here is the circumference as a function of the radius, and here's the area, or the radius, as a function of the area. You know, and how would you want to use this? Let's say you're trying to determine what's the radius of the pond at the barn. And let's assume for a second that the pond is a perfect circle. It's not, but we'll go with it. It's hard to go to the middle of the pond and measure what the radius is. That'd be hard to do. Now, instead, what we could do is we could walk around it, get the circumference, divide it by 2 pi, and that would give us our radius. Now, what if we combine these and said express the area as a function of the circumference? Well, if we look here, we know that r is the square root of a over pi. So I have my area is pi r squared. But my r is my circumference over 2 pi. And if I simplify this, I would get c squared over 4 pi. Now, think about what this does. This is a formula for the area of a circle that doesn't include the radius. If we go back to our pond analogy, if I just walk around the pond, measure the circumference, plug it into this formula, now I have the area. That's kind of where we're going. Could you do this in multiple steps by finding the radius in between? Yes, but we're looking at one step. So we want to kind of understand what variables we're solving for. This is another classic example. This is Fahrenheit equals 9/5 Celsius plus 32. This is changing temperatures. Now, let's say I want to come up with a formula, and you've seen this before in science probably, for Celsius. So if I knew Fahrenheit, I can easily calculate Celsius. Well, what I could do was subtract 32. Now if I multiply both sides by 5/9, I would just get C. Let's move this over here. We don't need that much room. C is 5/9 over F minus 32. These are examples of this is F as a function of C. Down here, this is C as a function of F. So it's just a matter of writing it the correct way to solve for the correct variable. So, the height of a cylinder is triple the diameter. Express the total surface area S as a function of the height. So let's talk about something here. First, the height is triple the diameter. So the height is equal to 3 times the diameter. We don't actually have the diameter here, we want the radius. And so we know the diameter is twice the radius. So our height is 6r. Now, let's talk about the surface area. Do we know the surface area of a cylinder? Well, we have the area of the top and area of the bottom, which is pi r squared, but there's the top and the bottom. So pi r squared is the area of the top plus the area of the bottom, that's 2, plus the area around the outside. And that is the height times the circumference of the circle, so that's 2 pi r h. Now, we want to express the total surface area as a function of the height. That means I only want h's in my equation. And I have 2 r's there. So I want to get rid of those and rewrite them in terms of h's. And this is where I use this piece over here. I know h over 6 is r. So I can plug that in. And I can get 2 pi h over 6 squared plus 2 pi h over 6 times h. And if we simplify a little bit, I get 2 pi h squared over 36 plus 2 pi h squared over 6. Now, if we want to try to get common denominators here, I am going to multiply by 6 over 6. So I get 2 pi h squared plus 12 pi h squared over 36. And finally, my surface area is 14 pi h squared over 36. So there is my surface area of this cylinder with only h. It has no r's in it. So that's what our goal is going to be. We're going to try to come up with these functions. And you really have to read this part here to see s as a function of height, to determine what variable do I keep, and then what variable do I use this other piece of information to get rid of. We are now ready for the first homework over the verbal descriptions. It is the first page. It is the front page. This homework has a couple pages to it. It's just the first page of the homework here. It is 1 to 6. And then stop at the end of that first page.